Module 1, Lesson 5, we are going to look at a section entitled Two Graphing Stories, or in other words, we're going to continue the same graphs that we've done in the last several lessons. However, two different scenarios are going to be illustrated on one graph at the same time. So, thus, our instructional outcomes are to interpret the meaning of features appearing in graphs related to real-world situations, and to interpret the meaning of the point of intersection of two different graphs using analytic tools to find its coordinates. So, the first scenario that the students look at in class is example 1 found on page 21 of their student handbook, and they offer this story for them to think about and consider in pairs. It says that Maya and Earl live at opposite ends of the hallway in their apartment building. Their doors are 50 feet apart. They each start at their door and walk at a steady pace towards each other and stop when they meet. What would their graphing stories look like if we put them on the same graph? When the two people meet in the hallway, what would be happening on the graph? And then to sketch a graph that shows their distance to Maya's door. So again, the students start off in pairs, and they're there to think and sketch and come up with ideas as to what they believe is going to happen. In the end, one thing that we want to note is that we want to observe the distance from Maya's door in feet will be our y-axis, and for purpose of design, time in seconds is what we're looking at in that purpose and that design. So in the end, when the students are done with their sketch, we hope that they come up with this idea here, to where when we look at it, this is the distance where one person starts at, the distance from Maya's door, and this is the person, Maya, starting at Maya's door. And so again, the scenario is that they're at opposite ends of the hallway, their doors 50 feet apart, so we know that this distance here is roughly 50 feet from point and then to point, and if they start walking towards each other, then this person will be walking closer to Maya's door, and Maya herself will be walking away from her door. And then at some point, where the graph stops at right here, or is what is known as the intersection point, is a location in which they meet in the hallway. In example number 2, we're going to look at another video similar to the stair video that we looked at in lesson 1. And again, this is a class discussion piece where the teacher is going to ask the students, what did we observe? What did we see happening? And the teacher may watch the video with the students multiple times to show what's going on. So here's our stairwell. We have Dad walking up the stairs. And when he gets up to the top of the stairwell, he's up there for a few seconds, so he doesn't instantly come back down. But then what we see introduced into the picture in just a moment is Dad coming back down, but then his daughter walking up while he's going down. And so the question is, what does the student observe in terms of a graphical analysis, and what do they think this should be described as? And so in class, they're sitting there and they're talking and discussing, and they're just writing down whatever ideas that they think come up with in this particular piece. Ultimately, we want the students in small groups to get together and create a graph, an elevation versus time graph, that illustrates the man and the girl walking on the same stairway. After the students come up with some thought and thinking, this is the graph that they develop, or something along this idea. And of course, this is guided by the teacher to help them figure out what's going on. So what are we looking at in terms of perspective? Person number 1 here, this is our dad. This is Dad starting at the bottom of the staircase. He's going up in this general fashion until he reaches the top of the staircase. We know that he stays at the staircase top for a few seconds before coming back down. And on his way down, his daughter which starts at this point in the video, this many seconds past the original starting time, begins to go up the stairs. Here we have point P, the location where they're at, same point on the stairwell where dad is going down and daughter is going up in that particular direction. So one of the questions a teacher might ask is, does it seem reasonable to say that each graph is composed of linear segments? The teacher is looking for the student to say yes in this design because this is a straight line, another straight line, and down a straight line, and then the girl's movement is in a linear path forward as well. Then a theoretical question comes up saying, suppose the two graphs intersect at point 24, 2. Now, we didn't actually look in the video as the timing, but let's just say point P is 24, and then 4. What is the meaning of this point in the situation? Well, we look at it, this is our x versus our y. So if we look at this as our y-axis and our x-axis, we're referring to this 24 as being 24 seconds into the video, and they are 4 feet off the ground. Is it possible for two people walking in stairwells to produce the same graph and not pass each other? This is a complete theoretical question for students to ask and discuss in the classroom. There is not necessarily a right or wrong answer. Some students may say no, that you can't go up and down a staircase, two people at the same time without passing, while other students may argue you could have two staircases at different parts of the building with one student going up and one student going down, and then based on that assessment, no, they would not pass each other because they are in different parts of the building. So it is just thought-provoking and not necessarily something a student has to get right or wrong in that question. In example 3 on page 22, we'll look at one more scenario. This time we're hoping the students have an opportunity to work individual on this one and then share out in pairs or small groups then as a class as to what's going on. So in this story it says Duke starts at the base of a ramp and walks up at a constant rate. His elevation increases by 3 feet every single second. So we're going to mark that 3 feet every single second, and that's for Duke. Just as Duke is starting to walk up the ramp, Shirley starts at the top and walks the same 25-foot ramp going downwards at a constant rate. Her elevation, it says, decreases by 2 feet for every single second. So here we have a situation where one person is starting at the top of a ramp and one person is starting at the bottom. So if we looked at Duke, Duke starts down here at the bottom and is going up 3 feet every single second. So we go up to 3 and then go over to 1. We go up 3 more to take us to 6, go up another 1, and we can continue on if we went up another 3 and then over another 1 and continue our dots. Now Shirley is the same thing, only the interesting thing with Shirley, it says she starts at the top of the 25-foot ramp, so we're going to start Shirley up here at 25. And it says she's going to decrease 2 feet every single second, so if I'm at 25, then I'm at 23 over at 1 second. Then I go down another 2 and over another 1. And what we're looking at to ultimately see and ultimately define is that as Shirley is going down and Duke is going up, we're going to see that they will intersect at some point along this graph. And so we can see the full dots and the graphs here. And we look at this and observe that as Shirley is going down and Duke is going up, they do in fact intersect at this particular time frame on the graph right here. So then the question is, what are the coordinates of the point of intersection of the two graphs? So when we look at that, if that location is at 5, 15. So we would write 5, 15 for this intersection point right there. At what time do Duke and Shirley pass each other? That would be at 5 seconds. 5 seconds into that time frame. And then finally, they're asking us in this story to write down the equation of the line that represents Duke's motion up the ramp and the equation that represents Shirley's line down the ramp. So that involves a student having the ability to work with the linear equation y equals mx plus b, where m is our slope and the b is their y-intercept, or in other words, where they started from in the graph. So if we wanted to illustrate Duke, we know that Duke started down here at 0. So his y-intercept would be 0. And it stated in the story that he was going up 3 feet every single second. And so that would be our slope, 3 over 1, and then x, and then we'll put a plus back here. That's for Duke. If we wanted to illustrate Shirley's equation, well, she didn't start on the ground. She started up here at the top of the ramp at 25 feet above the ground. So we could start by writing 25 for Shirley. And then it said that she was decreasing 2 feet for every single second. So then we would write y equals negative for down, 2 over 1. And then we can put an x right here to represent time passing in our seconds. In closing, the teacher brings up this notion about Shirley and Duke's scenario. Perhaps this question here: how did you figure out the slope of your linear equation from the story? And so we want students to be able to express, well, they said, well, based on the story, it went up 3 and over 1, which models our rise over our run. And that gets repeated here, up 3 over 1, up 3 over 1. Why was Shirley's slope negative? Well, simply by the language we talk when we discuss this. This is starting here. We'll go down 2 over 1, down 2 over 1, down 2 over 1. And it is that keyword down that we're looking for that explains why Shirley's slope is negative. Why did Shirley's graph and equation have the y-intercept as 0, 25? Well, again, the students want to be able to explain to the teacher that she started at 25 feet above the ground at the top of the ramp. And then what was easier in this problem to determine the intersection point algebraically or graphically? And so that would be something the teachers may discuss with the student. They may not, depends on the time in the class. This is not something that the student needs to be able to do on the upcoming test first, so it is just really for discussion. But we do want the students to understand in this lesson that the intersection point of the graph of two equations is an ordered pair that is a solution to both. In other words, it is something that they both have in common with each other. So in context of the distance or the story, this point represents the fact that both distances or elevations are equal at that given time.